Hello viewers, welcome back to class. I'm super excited to welcome you back to class. You are welcome to Master Builders Online Academy. So if you are new in this channel, do consider subscribing to our channel and ensure that you turn on the post notification bell for more exciting videos. For your own advantage, do not skip any part of this video. Ensure that you avoid every unnecessary distraction anytime you are set to watch and to learn new concepts from this platform. And finally, if there be any part in this video that you do not understand, when you watch it for the very first time, guys, you have the opportunity to replay the video over and over again until you understand it. Of course, yes, I believe that you can understand it. So, all you need to do is to replay the video over and over again and ensure that at the end of watching this video, like this video, share this video, and make your necessary comment. Like I do always tell you, your comment can be in form of questions, it can be in form of appreciation, or it can be in form of suggestion or opinion as to how we can improve on our services for your own benefit. So guys, if this is understood, let's get to the business of the day. On the board, we have calculus, integration of functions. And now we are going to be integrating, we shall be integrating polynomial functions. Integration of polynomial functions is what we have before us. Now, we already know what polynomial functions are. So this is no longer something we should ponder on for a very long time before we can get to know it. And that's the reason why I say you get to understand the basic functions in mathematics. Now listen carefully. In your exams, nobody will state that this is polynomial function, this is trig function, this is hyperbolic function, this is exponential function, or this is inverse function. You will be the one to identify it. And that's the reason why you see me hammering on these things. Ensure that you get to understand function, because that is where your solution starts from. Ability to understand or the given function is what gives you the first foundation, the first thing, is what gives you the light to the first step that you will take. So when you understand the function, then you know how such functions are treated, what you do to such functions to get the required answer. Now guys, let's continue from where we started. Now we have asked to find the integral following integrals. The question can ask you to evaluate, you can be asked to find the integral, you can be asked to integrate. It's as simple as that. Or you may not be asked to integrate, you can be asked to what? Evaluate. When you have this integral sign in any function, of course you know that it is only in integration that you have a function like this. This is an integral. So anytime you are given a question, you are asked to evaluate, not integrate, not find the integral, and you have the function enclosed with this, alongside with the x or d of any other function. Directly you are asked, indirectly you are asked to integrate that function. So understand that questions in integration can come either by asking you to what? Evaluate the equation, but there must be an integral sign, or find the integral or integrate the following functions. If this is understood, now let's look at this. Then finally, there is something we could not look at when we were looking at standard integral. Now listen carefully, when we were looking at this in differentiation, we said if I differentiate a with respect to x, and being that a is constant, dy over dx is equal to 0. But what happens if I integrate a constant? Now, anytime you integrate a constant, you indirectly influence what you have by x. So if I integrate a, I have ax. If I integrate 3, I have 3x. If I integrate 100, I have 100x. If I integrate 1 million, I have 1 million x. It's as simple as this. Alright? Now, if this is understood, then let's fall back to where we started. Now, at this point, we have question number 1. Y is equal to integral of x raised to power 5 dx. Therefore, when you integrate a function, all you do is to increase the power by 1. Since we have identified that this is a polynomial function, so we just come here and have 5 plus 1 all over 5 plus 1 or plus c. Now, therefore, y would have given us x raised to the power of 6 over 6 plus c. This is the answer to this question. And like I explained earlier, anytime you integrate a function, you must add, is a must, you must add this constant, which we call arbitrary constant. So don't forget any function at all. Once you integrate a function or you remove the integral from any given function, you must introduce a constant. Now let's look at question number 2. We have 1 is equal to integral of 6x squared plus 4x minus 5 all dx. Now with this question, just the same way when you are giving long polynomial function to differentiate, you differentiate them individually. The same thing happens here. Now I can further explain this as y is equal to integral of 6x squared dx plus integral of 4x dx minus integral of 5 dx. I don't say you must do it this way. You must not do it this way. But this is an extension of what we have here. So it means that we are integrating these functions individually. Now, to integrate this first function, we have to increase the power by 1. Originally, I have 2 here, so when I add 1 to 2, I will have 3. This will give us 6x raised to the power 3. Now we will divide the outcome by the new power, all over 3. Then plus, I will come to this point, I have this as 4x dx. When I integrate 4x with respect to x, understand that x here has the power of 1. So when I increase the power by 1, I have 4x raised to the power 4, x raised to the power 2. Now divide the whole function by 2. Then when I integrate 5 dx, of course I know that 5 is a constant. And I just explained in some minutes back that anytime you integrate a constant, you influence the function by an x, then you add your constant. Then at this point, if you find out that the numerator here is divisible by the denominator, then you can go ahead and cancel out. Of course, 6 is divisible by 3. 6 divided by 3, we have 2x cubed. 4 divided by 2, we have 2x squared minus 5x plus c. This becomes the answer to question number 2. As simple as this. Now, number 3, we have that y is equal to integral of 1 plus x squared all dx. So by extension, we don't have to do this again. I just have to integrate 1 with respect to x, integrate x with respect to x, and integrate x squared with respect to x. Now understand that 1 here is a constant. And when you integrate constant, you now have 1x. Of course, we cannot put down 1x, we simply put down x. When I integrate x with respect to x, of course, x has the power of 1. Now, if I integrate x raised to the power of 1, I will add 1 to the power, then it becomes 2. I will have plus x raised to the power of 2, now divided the function by 2. Then at this point, we have this as x raised to the power of 2. Now, when I integrate this, I will equally increase the power by 1. I will have this as x raised to the power of 3 all over 3 plus the constant. So, guys, this is the answer to this very question. Now, we can head on to solving question number 4. Now, you see that this thing is very, very easy. So easy. It is very easy. All you just need to do is to understand the function that you are dealing with. Now, question number 4. We have that y is equal to integral of x raised to the power of 4 minus 3x raised to the power of 2 plus 10x, 10 all dx. The same way, we are integrating each of these terms with respect to x. So when I integrate x raised to the power of 4 with respect to x, I will increase the power by 1. This will become 5. Then divide the function by 5. Minus, when I integrate this, I will increase the power here by 1. And when I add 1 to this, will have given us 3x raised to the power of 3. Now divide the whole function by 3. Now the next is the constant. When I integrate 10 with respect to x, this will have given us 10x, then plus c. Now I have a denominator. If I find out that there is something that can cancel out, or the numerator can be divided by the denominator, then I can go ahead. Of course, I can take care of this middle term. Then I have this as x raised to the power of 5 over 5 minus s cubed plus 10x plus c. This is the answer to this. Then finally we have question number 5 on the board. Now question number 5. We are asked to integrate s cubed over 2 minus s squared over 3 minus x over 4 or dx. This is what we have. Now all I just need to do is to look closely. Now when we look at this, of course this question came as a fraction. But the interest here is, where is the s located? Is it at the numerator or at the denominator? Why am I explaining this in this way? Understand that when you have x at the numerator, the way you will treat this is different from when you have x at the denominator. So when you have x at the numerator, it is still a polynomial function, direct polynomial. But when you have x at the denominator, then you have inverse. So the way you treat inverse polynomial function is different from the way you treat direct polynomial function. So you watch out for where you have x, either at the numerator or at the denominator. So here we have x at the numerator. So we are going to treat this question the same way we treated all the ones that are here. We are quickly going to look at a case where we have x at the denominator when we have constants at the numerator. Now in this case, all I just need to do is to integrate this. And now identify the function of s. This is the first function. We are integrating s raised to the power of 3 over 2 with respect to x. And now when we integrate this with respect to x, we will increase the power by 1. Now become 4 all over. Now bring down the power, which is 4. 4 will multiply the existing denominator. Now the existing denominator here is 2. So 2 multiplied by the new power 4, this will have given us 8. Minus, here this is the second term. When we integrate s squared over 3 with respect to x, this will have given us, when we increase the power by 1, this will have given us x raised to the power of 3 all over 3, which is the existing denominator, multiplied by the new power. And 3 multiplied by 3, this will have given us 9. Then finally, when we integrate this guy, when we integrate s raised to the power of 1, this will have become s raised to the power of 2. Now the new power is 2. 2 multiplied by the existing denominator would have given us 8. This becomes over 8 plus 2. This is the answer to this very question. So guys, you see that integration is very simple. Just the same way differentiation is simple. All you just need to do is to understand principles that works. When you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep boundaries. So guys, at this point, if you have not subscribed to this YouTube channel, please consider subscribing to this channel and do ensure you turn on the post notification bell for more exciting videos. Guys, you can check the description below where you will find the link to the next lesson. Share this video, like this video, and make necessary comments. Thanks for watching. See you guys in